Section 2.3 is the sine law. Okay, so first of all, a triangle that does not contain a right angle is called an oblique. You can use the sine law to solve problems involving oblique triangles. To find the side length, you must know the measure of the angle opposite plus one other angle opposite side pair. So this is the case when we're looking at angle, side, angle. And this is a relationship that exists. The ratio of side A to the sine of A is equal to the ratio of B to the sine of B is equal to C to the sine of C. Okay? Okay. The problem lies, there's some ambiguity. To find the angle, you must know the length of the side opposite that angle plus one other side pair. Note that there are two solutions for any sine theta between 0 and 180. One solution is an acute, one's in quadrant 1, and the other is an obtuse. This is known as the ambiguous case. So in this case, the sine of 40, so the sine of 40 is equal to, if I had a reference angle of 40, if I had an angle of 180, those two things are the same. Your calculator is only going to give you the small answer, but we could also be talking about the sine of 140. So when we're solving, it doesn't tell us which one we're getting. So there is a chance for ambiguity. And ambiguity means, okay, which one are you talking about? It's ambiguous if you're talking about this or that. Okay, so in order to determine if we're talking about ambiguous or not, we need to determine the height. Okay, and so to find the height of something, to find this, since we know an angle and a side, we're going to say, well, height is equal to, well, first of all, what they did is they said sine A, oops, sine A, so SOHCAHTOA, the opposite is H over B. So opposite over that. So they solved for H. They said H is equal to B sine A. So they're determining that height. That's why we did H. So we use the altitude or the height to determine if there's 0, 1, or 2 triangles. So here's all the cases. If A is less than height, or A is less than B sine A, remember height is just B sine A, there's no triangles. Okay? If A is equal to H or A is equal to B sine A, then angle B is 90. If A is greater than B, it's one triangle and two triangles in this case. So you can kind of visualize what they're talking about here. If A is too short, no triangle, no matter how much we swing that. Okay, here if A is exactly equal to the height, there's only one possible triangle, a 90-degree. If it's less than B, we can, or sorry, greater than B, there's only one part, because if we swing it out over here, we're not going to get another triangle. Okay? The other case is that the height is less than A, but A is less than B. There's actually two ways that we could get a triangle. We could get a triangle, this one first triangle, or we could swing and get a triangle there. Okay, so whenever we use the sine law, we have to look for ambiguity. Okay, and when it's obtuse, when we start with a bigger than 90 angle, there's either no triangles or one triangle, depending on what we're looking at. Okay, so what does that look like in terms of a question? In triangle ABC, A is 48, B is 6.4, and angle A is 18. Solve the triangle. Round angles, whatever. So sketch a diagram. Place A in the lower left. So here I have a triangle AB. Oh gosh, I should go to art school. Okay, so this is A. Right across from big A, this little a, that's convention. Okay, and I know B, so this must be angle B. My known information. A is equal to 4.8. Oh, sorry, that's not true. Angle A is equal to 18. Side A is 4.8. Side B is 6.4. If A is an acute and A is less than B, we need to calculate the altitude. So was A less than B? 4.8 was less than, yep. So we need to go B sine A to find that height. So B is 6.4. times the sine of 18. And we're going to get out a calculator to do that. So in my calculator, I have to go, and every calculator is different. Make sure that you are in degrees and not radians. If you have an RAD instead of a DRD, you're in trouble. I think in my calculator, I have to go 18. Oops. I have to have a calculator, first of all. I think I go 18 then sine. 18, my one button's not working good. And then my sine button, that's what I have to do, yeah. And then times by 6.4. Some people can do sine 18 instead of 18 sine, depending on your calculator, is 1.97. Okay, 1.9777. Okay, since the height is less than A, yep, this is less than that. This is less than that. How many triangles do I have? So I have A, H is less than A, is less than B. Let's see. Let's look at our rules that we will write out. Means that we have two possible triangles. Okay? It means that there are two possible triangles. So we have to look at both cases. So it says solving a triangle means to find the measures of all the angles. Since there are two triangles, you complete two full sets of calculations. So look, this triangle has angle 18, side 6.4, and side 4.8, but so does this one. So there's two triangles that they could be talking about. So first of all, we're going to look at B being acute, so a small angle for B. So we use the sine ratio, sine A equals sine B, sine A over A equals sine B over B. Notice that this isn't exactly the same. You can also flip them, as long as you flip both of them. Okay. So we're putting a number, sine 18 divided by 4.8 is sine B over 6.4 times both sides by 6.4, inverse sine. Okay, so how are we going to enter this into our calculator? Very carefully. We are, in my calculator, I have to go 18, my one button, 18 sine, okay, times 6.4 divided by 4.8. Now I have to inverse sine. So I think I go inverse sine, and I get 24.3. 24.3. And they just said, remember from the question, they said round to the nearest degree. So that's why we're just going to use 24. So to find angle C, so now we say, well, this is 24. So they say, well, to find the rest of that, I just take 180 and I subtract the two angles I have and whatever's left. Okay, so we go 180 minus 18 minus 24, 180 minus 18 minus 24, 138. Now we need to calculate side C. We set up the sine law, the ratio of a side to the sine of its angle. Okay, and we would solve for C. So we're, just to be sure, it better be longer than 6.4 because that's the longest side. I'm not going to spend time showing how to do this. Okay, the second triangle. To calculate angle B, find the angle in quadrant 2 with a reference angle of 24. Because the sine, remember we said the sine of an angle, that was the ambiguous part. Sorry. The sine of an angle and the sine of an angle in the second quadrant with the same reference angle are going to be the same. Oh, I have definitely gone to the wrong page. Okay, so they said all we have to do is find that reference angle. Well, 180 minus 20 is 160 minus another 4 is 156. Okay, so now to find angle C, we go 180 minus 56 minus, sorry, 156 minus 18, because we already had those first 18 degrees right there. Okay, so I'm going to take out my calculator, 180 minus 156, oops, I didn't get to 100, minus 18. I tell you, my 1 button doesn't work. Okay, so I'm left with 6 degrees. And that makes sense. So that would be about 6 degrees. Okay, it's just tiny. So there we have that. And then we can use the sine law. So A over sine A, or we could use B over sine B. But we do want to know C over sine C. We're going to use our 6 degrees there. The sine of 6 degrees, we're going to use A, which we found was, well, which was given to us was 18. And our side length is 6.4. And here we're going to solve for the side length, okay? So there's 2 possible triangles. So just to note, these are very important. We're always going to be looking here to determine if there's 1, 2, or no triangles, okay? Because the sine law is ambiguous, because the sine of an angle is equal to the sine of another angle in quadrant 2, because they're both positive in quadrant 1 and quadrant 2. And in a triangle, you can have a obtuse angle. Okay? So lots of questions we'll have to do and lots of practice.